Hello, in this video we will show a simple neural network model with R. So first we will introduce briefly what is the neural network. So this figure shows a very simple neural network model. So neural network means there is a neural layer, and this layer is part of the model and connects with the input features. This, for example, this is one observation, and this is a feature x1, x2, x3 for this observation or example in the machine learning. Then, with a connection from this layer, and this layer includes several, for example, 16 or 32 neurons. And each neuron is kind of operation. And this operation with a weight parameter for each neuron connects the inputs, and with the summation of the time together of these parts, then with a function. So first is a sigma operation, because we sum all the product with the weight and the feature together, then take a function, and this function called activation function. And activation function is the key part of the neural network. So we usually, the default activation function is sigmoid function or the logistic function like this. So for example, this is the input, summation of the input times the parameter together, then summation together. So this is a linear part, but with this activation function, we can model the nonlinear part. So this is the key part of the neural network. So which can model very complicate information flow from the input to the output. So this is the neural part. So F here is the activation function, and this is the sigma with the product between weight and feature. So this is the basics of the neural network model. And next we will show an example which model to predict the relationship between ingredients of the concrete and the strength of the concrete. And you can download this file from this website's download link. So next we go to RStudio. We go to this file and we set the working directory and load a CSV file called concrete. So we use a read CSV function. Then concrete is a data frame, and we use str function to show the information of this data frame. So you can see there is 1030 observations with 9 variables, and all the variables excluding the age and numeric, which is integer, and the strength will be used as the target variable. All the other variables will be used as features. And before we use this model, we have to normalize, because you can see different features have different scales very differently, and we have to scale or standardize these features to the same scale. We use minimum, maximum scale function. Then we create a new data frame using apply function to normalize all the variables of this old data frame. So this is the new one, and for example, we show the summary of the variable strength in the new normalized data frame. So you can see there is minimum to maximum 0 to 1. And if we shoot original feature, it will be from 2 to 82. So we create a training data and test data. So model will be trained on the training data, and the trained model will be used to test the data to see the performance. Then we load this library called neuralnet, and you have to install this package first. So this package is loaded, and we set the random seed first. Then first we create a model using only one neuron. So this layer has only one neuron. And the left side of this function formula equals on the left side of this tilde function, tilde symbol is the strength. On the right side is all other variables we want to model, and the data is this training data frame. So it is very quick because it has only one neuron. Then we can plot this model. See, so you can see input feature to this neuron, and when it means the BS term. So multiply together this line, each line means a parameter, weight parameter, or means the operation for multiplication. So feature times parameter times weight, then sum together, then plus a BS term. Then have a function here, then this is output, and we get another BS term, then get the resulting strength, right? So the error, can remember error about 5.077 and with steps 4,800. Then we can see the model performance. The result is compute. This is for the test, for the trained model to test the data. So we use a compute function with this trained model and with the test dataset. Those test dataset have to be the same feature. So we use 1 to 8, and the result can be seen from this resulting list, and we use net.result element. And this is the resulting predicted strength. Then, because this is a continuous variable, so we have to use correlation between the known strength value and this predicted value. So you can see the correlation is 0.8, not bad, but it's not perfect. So next we can improve this model by adding neurons. Here we set 5 neurons, so the hidden option is 5, and the model structure is the same for in accordance with the variables, so strengths and other variables on the right side. It takes 1 minute maybe, because it just uses CPU, not use GPU now. So now it is finished, about less than 1 minute. Then we can plot this model structure. So this time there are 5 neurons. So each neuron has connection with a feature. So this is called, the model structure be called MLP. So multi-layer perception. Perception model means the full connected. So each neuron connected with each feature. So you can imagine if there are 100 neurons and their features, so many parameters. But we just focus on the result performance. So each connection with a neuron and with this one will be a BS term. And similarly, same for this one. So after BS term, addition with this multiplication, we will take a function, activation function, and default is logistic. Then the result will be summed together. And with the parameter, the result from this output layer will multiply with the parameter here. There are also parameter. Then with addition of Beer's term. So the result will be the stress. So you can also use this model to predict with the test data, and we show this result, and we also calculate the predicted results, calculate the correlation between the predicted results and the observed results. So now you can see the model performance is much better with 0.92 after we have used only 5 neurons. So in this video, we have showed just the basics of the neural net function in R to model a very simple perception full connected neural network. And if you are interested in, you can view the description of this package and show how to model more complicated data. Thanks for watching.